Welcome to the third grade just-in-time session. This is our first session. We are going to be going over content for the second 9 weeks. My name is Teresa Carroll. I'm the Elementary Math Curriculum Coordinator. Please feel free to reach out to me via email or phone if you have any questions about what we talk about in our slide presentation or about anything else mathematically related. Our agenda for this portion, instead of recording for the whole hour, I'm going to break it up into sections. This first section is going to cover the welcome and purpose of the just-in-time sessions. We're also going to talk about reevaluating what it means to be good in math. And we're going to go over ongoing review in this video. The second video is going to go over the the modules that will be covered the second 9 weeks. We'll talk about priority standards, the data that goes along with those priority standards, as well as some daily lesson that are in the standards that we need to focus on. And finally, the third video is going to cover a fresh look at the hard to teach, hard to learn skills, including a brand new resource to help you teach them. So for our first video in this segment for our first just-in-time, we're going to start by talking about reevaluating what does it mean to be good at math. This video is on YouTube. I'm going to link it separately. We're not going to go through it right now, but the person that recorded this video talked about how math isn't always about being an abstract thinker. For some reason, we think that getting to abstract island, in this case, that's the analogy that he used, that getting to abstract island is the goal, and that's not necessarily true. We have to provide students with opportunities to work with conceptual and application level practice, and we need to stop rushing students to the abstract algorithm. Rather, he talks about a strong math student is one that purposefully builds bridges between concrete and representational thinking and can fluidly move back and forth between both of those ways of thinking. A person that's good at math has purposefully built a strong bridge between representational thinking and abstract thinking and can move fluidly back and forth between those two islands. It's a really, really great video. It's only about 7 minutes long. I highly suggest that you watch it when you get a chance. And I will be referencing the bridges later on in this session. The main rock that we're going to cover in this video session is ongoing review. Ongoing review should be blocked out the first 20 minutes of your math block, 3 consecutive days a week. The other 2 days of the week, you are supposed to be using that 20 minutes to reteach Tier 1 content that you've decided at your data meetings needed to be retaught. So let's dig into ongoing review a little bit. The ongoing review routine has been modified for this year if you used it last year in the past. It follows the read, draw, write problem-solving model incorporated in Bluebonnet. So the students will first start on day 1 by reading the given problem. They will draw a mathematical representation, like a strip diagram, for example, and label the parts of it. They will write a number sentence or an equation to solve the problem and then go ahead and solve it. And then they will write their answer in a complete sentence. All of that takes place on day 1. Shouldn't really take more than 5 or 7 minutes. And then any extra time that you take up to the 20 can be banked for your regular math block. That's essentially what day 1 looks like. Each set of the ongoing review is designed to be used on 3 consecutive days during the week. And each of the ongoing review sessions within that set is designed to be completed in about 10 minutes. So again, the first day, as I said, they're going to be given a problem. They're going to use the read, draw, write process to solve it. That's day 1. They turn it in. Before day 2, the teacher takes those, I call them entrance slips, takes those entrance slips and sorts them into 2 piles. The pile of students that got it correct and understand, and the pile of students that aren't quite there yet. Then the teacher will look through the not there yet pile and choose their favorite no. Then the teacher will bring the student's work, the favorite no, the student who didn't get it correct. And on day 2, they're going to spend some time reflecting on that student's work. It's an opportunity for teachers to guide their thinking and clear up any misconceptions that might be arising with that problem. Then on the 3rd day, they're going to compare and contrast the problem they've been working on, all of the skills, all of the content that it takes to solve that problem, to a new problem That is the same standard, but it looks different. Maybe it has a table where the first one didn't. Maybe it's multiple choice where the first one was drag and drop. Whatever the difference is, they're going to describe how they are the same, both what the problem looks like and sounds like, how they're different, and how the process of solving the new problem is going to be the same and how it's going to be different. All right, so we've talked kind of just in generality what that's going to look like. Let's dig in and actually look at an example. There it goes. Okay, so in this example, we're looking at set 6. Set 6 is going to cover representing and solving 1- and 2-step problems with multiplication and division. So on the very first exercise, they are given the problem on the left. You'll print those out, project them, and they'll do their work on paper, however you choose to do it. The students will read the problem. A sports complex has 4 basketball courts. There are 2 bags of basketballs for each court. Each bag contains 10 basketballs. Complete the equation to represent the total number of basketballs at the sports complex. So after they read the problem, they're going to draw a mathematical representation and label it. Maybe they draw a strip diagram. Maybe they draw 4 circles for the basketball courts. They put 2 boxes inside each circle for the bags of basketballs. And then they write a 10 inside each box to represent the 10 basketballs that are in each bag. Either way, they get some kind of mathematical representation to guide their thinking. Then they're going to write a number sentence that they're going to use to solve it. Go ahead and solve it. And then they're going to write their answer in a complete sentence. It's only one problem, shouldn't take more than 5 or 7 minutes. They're doing it independently, and then they're turning it in. The teacher will then collect the problems, and sort them into the yes, they've got it pile, or no, they don't have it yet. And for exercise 2, they will choose their favorite no. It's very important that the teacher purposefully chooses amongst the no pile. Maybe we're looking for a common misconception that we want to bring to light for the class so that hopefully they will learn from that misconception. Maybe the student was super close to having the right answer but stopped just short of the right answer. Maybe the student made a silly mistake that sometimes happens. Whatever this teacher chooses to use, make sure there's a valid reason for purpose for using that student's work. Then they will erase the student's name and either just stick it under a document camera. You can be fancy and take a picture of it and upload it to the slide deck, whatever works for you. But once the students are looking at the student work, we're going to start with what about this student's work makes me happy. So we're going to start from like an asset-based lens, a positive lens. Every student can do math. Every student can do something towards getting to the correct answer. So analyzing the student work, what did the student do right? Maybe the student used strategies that you have been teaching them to do. Maybe the student drew an accurate mathematical representation or attempted to. Maybe the student knew that they were going to multiply first, but they got the second step wrong. But either way, you're starting off with talking about the positives, setting that positive mathematical culture. What about the student's work makes me happy? What else am I happy about? After you've listed all of the positive attributes of the student's work, then you ask, where do you see a problem with this person's work? This gives them the opportunity to analyze the error, identify it, stamp the misconception, and then hopefully through that mathematical discussion, they'll learn from that mistake and not make that mistake again. That is the end of day 2. Again, shouldn't take more than 10 minutes. And then for day 3, you're going to project this slide. This is the problem they've been working with all week. And right next to it is a new problem that covers the same standard. So they're going to read the new problem, and then they're going to talk about how are the 2 assessment items similar and how are they different. Well, both of them are multi-step problems. Both of them involve equal groups. This problem, all the information was in a paragraph. This problem, it's bulleted out. This problem was drag or drop and we were multiplying twice. This problem is multiple choice and it doesn't look like multiplying twice is an option, so we're not going to be doing that. And then how is the process of solving this problem similar or different from previous problems? So you've had a good discussion yesterday about this problem. You have some tools in your tool belt to solve this problem. Which of those tools are going to help me with this problem? And is there maybe a new tool that we need to talk about in order to be successful in this problem? Once you've had a good, rich discussion, you pass out the exit ticket, which is linked down at the bottom. This second problem is the exit ticket. And then the students will complete it and turn it in. It's a good way for you to kind of check and see formative assessment. Are they progressing towards understanding this, or are they still having trouble? And that's it. Very, very powerful. It is the best opportunity we have in our curriculum to not only spiral content, because all of the ongoing review questions come from previously taught standards. There is no new content on ongoing review. And it is a good chance to look at what problems look like on STAR, because most of the problems featured in ongoing review were STAR released problems. Okay, that is the end of our first video.